So let us discuss about the difference between dielectric and insulators. So dielectric and insulator both can be classified belongs to insulator group. Both never conduct electricity. But if you take a pure insulator, some wood, the wood never respond to an electric field. If you expose a wood to an external electric field, you cannot feel any kind of response from the wood. But some other materials, if you expose these material to electric field, there is a polarization of charge particle will happen. That means in that materials the bonding is very loosely connected. The bonding of molecules are loosely connected. So what will happen? There is an alignment of charge particles. One side negative charge particles will get aligned. On the other side the positive charge particles will get aligned. So this alignment of charge particle is because of the external electric field. And here we can see two plates, just like a parallel plate capacitors. One side is plus charge, another side is minus charge. So there is an external electric field. In between there is we can see a dielectric medium. It is sandwiched between this plate, and we can see that due to this charge plate, there is an external electric field around this dielectric material. So what will happen? It will polarize in sense of the charges, the positive charge and negative charges, they try to realign its position. So one type of group of charge particle will align to one side, and other the opposite charge particle get aligned to other side. So what will happen? There is an electric dipole will create. There is a charge will create. But these materials never conduct electricity. But they will respond to electric field, external electric field. The current never flow through this dielectric mediums. Let us see that there is a very good illustration about the dielectric response of atom. So here we can see that it is a nucleus, and around the nucleus we can see a electron cloud. This is the concept as per the Schrödinger's atom concept. The electron is just like a cloud around the nucleus. So the cloud represents the probability of electrons. You cannot exactly point out that where the electron is located in the cloud. The cloud represents the probability of electrons. So now let us see that this is the circle represent the boundary of an atom. So it is a cloud. The cloud represent the negative charge particle, whereas the positive represent a nucleus. Now let us see what will happen in the next image when I applied an external electric field. So what will happen when I apply the external electric field? So one side the charges are trying to change its orientation. See, the cloud of electron is slightly shifting towards the positive. That means the electric field. This is the direction of the electric field. The cloud of electron is slightly changing its orientation, and whereas the nucleus will change to the other direction. So what will happen? There is equal and opposite charges are created. We can represent like this. See, here in this figure we can see that the shifting of the charge particle create a dipole. So dipole is nothing but two equal and opposite charges separated by a very small distance. Here we can see that the one side we can represent as plus q and another side we can represent as minus q. The distance between the plus and minus is in Armstrong. It is a very, very small unit. And so there is a dipole moment is created because of the shifting of this positive and negative particles because of the external electric field. Now what will happen if I remove this external electric field? If I remove this external electric field, the atom will back to its normal shape, where what will happen? The orientation will changes back to its original form, where the electron get uniformly distributed over the cloud, so around the nucleus. So this is the change, the change in orientation of the electron particle the charged particle because of the external electric field. So unlike wood, so here dielectric material, it may be anything. It may be mica, it may be pepper, impregnated oil, pepper. There are many other materials are there which we can use it as a dielectric medium. So these dielectric medium respond to the external electric field by shifting the location of the charged particle in response to the field. So in a material, dipoles may be aligned in a random fashion. So the net dipole moment is 0. But when I apply an electric field, what will happen? An electric field is applied. What will happen? So after that, the dipole will align like this way. The dipole will align in this fashion. So there is a net electric field is created.